Myself, I am Tony CJ, working as an assistant professor in the Department of Physics, Jyoti Engineering College, Cheruthurthi. Hello everybody, today we are going to discuss on fiber optics. So, first topic is optic fibers. Optic fibers are very fine, narrow, long and cylindrical transparent fibers of glass or plastic through which a light signal can be transmitted. So, in order to transmit the light signal or data, we are using a cylindrical shaped transparent fibers of glass. So, this is known as optic fibers. Okay, now fiber optics is a name of technology by which the light is propagated through the optic fiber. Okay, the technology name is fiber optics. So in communication system we have lots of application with the fiber optics. So in communication system mainly we are using fiber optics. So that is the backbone of today's communication system. So it is widely used for long, medium, short range communications. Okay, now we will discuss on the some basic principle behind the fiber optics. First concept is total internal reflection. Okay, here we can see that there are three figures. Okay, I will explain in detail. So the in first figure, this is the incident ray and I is the angle of incidence, and this is the refracted ray and R is the angle of refraction. Here the light rays are traveling from denser medium to rarer medium. Normally, if the light ray is traveling from denser medium to rarer medium, the refracted ray that you will be bent away from the normal. Okay, so this is a case in normally happening, and in second figure it is shown that the light ray again is traveling from denser medium to rarer medium. Okay, at a particular angle of incidence, what will happen? The refracted ray that will be traveling along the surface of separation between two medias. So this is the surface of separation between two medias. So this is the denser medium and this is the rarer medium. Normally the refracted ray that will be bent away from the normal. Okay, now here at a particular angle of incidence, this angle of incidence normally we will say this is the critical angle. That means at critical angle the refracted ray that will be traveling along the surface of separation between two medias. So this is the surface of separation between two medias. That means the angle of refraction that will be 90 degree. So this is the normal and this is the refracted ray that is through the surface of separation between two medias, and this is the angle of refraction. So whenever the angle of refraction is 90 degree, the particular angle of incidence is called a critical angle. Okay, so now we will go to the discussion on critical angle. So an angle of incidence in the denser medium, so this is the denser medium and theta c is the angle of incidence for which the refracted ray is traveling along the surface of separation between two medias. So this is the surface of separation between two medias, this is the angle of incidence, and R is the refracted ray. Now the angle of refraction is 90 degree. So when R is equal to 0, R is equal to 90, that means angle of incidence is called critical angle. This is the theta c. Now we will go to the third figure. Now if the angle of incidence is greater than critical angle, that means I greater than theta c, then you can see that this is the refracted ray. Now this refracted ray that will be reflected back to the same medium. Now this is the condition for total internal reflection. We can see that if a ray of light is incident at an angle of incidence, so this is the angle of incidence, and if the angle of incidence is greater than the critical angle, then the light ray will be reflected to the same medium. This phenomena is called total internal reflection. In fiber optics we can say that only the total internal reflection is happening. Okay, that means the light ray will be reflected back to the same medium. So if a ray of light is incident at an angle of incidence greater than the critical angle, the rays are not refracted. So if the angle of incidence greater than critical angle, the ray will not be refracted. It will be reflected only. It will be reflected to the same medium. The property of called total internal reflection. So for total internal reflection, we will have two conditions. First condition is the light ray that should be traveling from denser medium to rarer medium. So that is the condition number 1. And condition number 2, the angle of incidence that should be greater than critical angle. Okay. So this is the fundamental basic principle behind the fiber optics, that is total internal reflection.